We can also classify matter according to its composition, what the individual particles are made up of. So we have broad categories of pure substance or a mixture. In a pure substance, you only have one type of particle. It could be an atom or it could be a molecule. If we look at the water here in this fountain, my stylus is breaking, here in the fountain, and we zoom in, what we see is that all of the individual particles, the molecules that make up the water, are the same. There's only one kind of particle. Every water molecule has one oxygen atom and two hydrogen atoms. This is called a pure substance. In a mixture, we have two or more different types of atoms or molecules, and they're combined in variable proportions. Looking at these molecules, we see there are two kinds of atoms, right? There's oxygen atoms and hydrogen atoms, but the ratio is always the same, 2 hydrogens to 1 oxygen, and they're actually bound together in this way. So from the broad category of matter, we have pure substances and we have mixtures. So pure substances can be divided more into elements and compounds. And mixtures can be divided into homogeneous versus heterogeneous. So elements, these are pure substances. They cannot be broken down into simpler substances. Water is a compound, it's not an element. Because you can take water and separate those molecules into hydrogen and oxygen. It's going to require some energy, but it could be as simple as dropping a 9-volt battery in a glass of water. The electric current will pass through the water and you'll see bubbles coming off of each of the terminals. That's hydrogen gas and oxygen gas. You're taking the water apart into simpler substances. An element, you can't do that. You cannot take an oxygen atom apart into smaller substances. So using chemical transformation, we cannot decompose an element into simpler substances. All of the elements that we know about are on the periodic table. So we've got a periodic table on each side of the classroom. Inside the cover of your book, whether it's digital or paper, on the digital copy they give you front matter, that's where the periodic table is. Those are the elements that we know of. Now, they've been making new ones, but those are really unstable, and they do exist, but only for like a couple minutes and then they're gone. Compounds are taking 2 or more elements and combining them together. What makes this different from a mixture is that you have fixed, definite proportions. So combining, say, oxygen and carbon, you could make carbon dioxide or carbon monoxide. You could make 2 different compounds. Compounds are a lot more common than pure elements. If you go out and, dig in a mountain or something, you're going to find very few pure elements, but you're going to find lots and lots of different compounds. In a mixture, we've got things that are not chemically bonded together. They're just mixed together. They can be separated, and the proportions can vary. So you could have a little bit of oxygen and a lot of hydrogen. I don't know if I have a picture. Well, this will work. So here's a picture of the ocean. And up in the air, the predominant gases are oxygen and nitrogen. These are individual molecules of nitrogen and individual molecules of oxygen, but the ratio of oxygen to nitrogen could vary. It is a mixture, okay? If we look at water, the water particles are always the same, 2 hydrogens and 1 oxygen. And so it's a combination of 2 atoms, but they're stuck together. I think of taking little balls and super gluing them together. They're going to stick together unless you pry them apart. They're not going to come apart from each other, and they're fixed proportions. So this is a compound. This is a mixture. Now, you can have a compound and a mixture together, then we call the overall thing a mixture. Here, in the ocean, we have salt and water mixed together. And so we have the sodium ions and the chloride ions, and then we have the water molecules. If you study a river as it flows into the sea, the water that's coming from the river is fresh water. It contains almost no salt. As it gets into the delta, it begins mixing with the seawater and it becomes briny. It has some salt in it. And as you go further out, you get to the ocean and there's more salt. The water there is a mixture of salt and water. The amount of salt in the water can vary. Water itself is a compound. You can't have water that has a little more hydrogen in it or a little more oxygen in it. Okay, so that's an important distinction to make. We categorize mixtures by how uniformly they mix. We make use of a lot of prefixes and suffixes in chemistry, in science in general. So homogeneous and heterogeneous. These prefixes have meanings. Homo means the same, hetero means different. So in a homogeneous mixture, the two substances mix thoroughly. Can we think of something that might be a homogeneous mixture? Tea. Okay, so you take a tea bag and you put it in hot water, and the water turns brown, and you stir it up, and it's uniform, right? There's tea flavor uniformly throughout. What if I put some sugar in there? The sugar will dissolve and will mix thoroughly throughout. So tea, sugar, and water will mix. Heterogeneous is going to not mix uniformly. Chocolate chip cookies. Very good. Those sound good. So in a chocolate chip cookie, you have the cookie part, and then you have the yummy chocolate chip part, right? You can actually see that there's different sections, right? If you mix, say, salt and sand together, right? You stir them up. I don't know why you'd want to do that, but you could do that. But then you look at it, you can still see there's salt crystals and sand particles, and they could be separated. In a homogeneous mixture, it's more difficult to separate them. Another example would be like Italian salad dressing, oil and vinegar. Oil and vinegar don't mix very well. You can shake that salad dressing up and set the bottle down, and you can just watch the oil float to the top and the vinegar goes to the bottom. That's a heterogeneous mixture. Something like macaroni and cheese. You've got the noodles and you've got the cheese sauce. They're not homogeneously mixed. Something like cream of tomato soup, that's been all blended and so it's uniform throughout. That's a homogeneous mixture. Let's practice this. Classify each as a pure substance or a mixture. Then if it's a pure substance, decide is it an element or a compound. If it's a mixture, is it homogeneous or heterogeneous? So the mercury in a thermometer, that's a pure substance. Is it a compound or an element? It's an element. So that's a pure substance, PS, and that's an element. Mercury. If you memorized your element symbols, you should recognize that from the list of elements, right? Mercury is one of the elements on the periodic table. If you can't find it on the periodic table, it's not an element. How about exhaled air? Mixture. That would be a mixture. Homogeneous or heterogeneous? Well, normally it would be homogeneous. You've heard the expression blowing chunks. That would be heterogeneous, but that's not what they're talking about. In your exhaled air, there is some oxygen. There's a lot of carbon dioxide. There's water vapor, but it's all thoroughly mixed together. So that would be a homogeneous mixture. How about chicken noodle soup? That's a mixture. Homogeneous or heterogeneous? Hetero. You can actually see the different pieces in there, right? So that's heterogeneous. Hetero. Sugar. A pure substance. Compound or element? Compound. Now, depending on how much science or chemistry you've had, a question like that about the sugar might be a little more challenging for you to think about. So on an exam, I will try to only ask questions that should be obvious to everyone. Okay, any questions? This is just a summary of how we can classify matter according to its composition.